Here we are going to demonstrate how to an example of number 26 in assignment C, a chi-square test for randomness. And we are going to use a supporting document named Research Project and Hypothesis Testing, which will give us the steps to perform a chi-square test using the critical value approach. And for this now, we are going to use an example. Here it is, of assignment C, hypothesis testing, number 26, chi-square test for randomness. The topic will be snack booth patronage. The research question, how are the students patronizing the snack booths? That's the research question. And a response to that question, which is a hypothesis without empirical data, there is a factor affecting the patronage. So it's not a random activity according to that response, that hypothesis. So the objective is to determine how the students patronize the snack booths. So data have to be collected. Here it is. Snack booths, you've got 4 of them, A, B, C, and D. And the number of students observed, 50 was observed to go to A, 45 was observed to go to B, 30 were observed, to go to C, and 60 were observed to go to D. And this will be the values for the example, which will be different for the values from the assignment. The assignment has 93, 72, 40, and 75. Now, the first step is to identify the appropriate chi-square test, which of course we identified it to be a chi-square test for randomness. Second step is to state the pair of hypotheses, the null and the alternative, which of course we can view this as 2 persons debating. One is called the null, one is called the alternative. They are both observing the students patronizing the snackets, and one is saying, the null is saying, oh, this is a random activity, occurred due to chance. The alternative is saying, no, that's not a random activity. So this can be viewed as 2 persons debating. Now, when 2 persons are debating, you need a third person now to make a decision to see who wins the debate. And that third person now need a rule, okay? The rule now will be if you are doing a critical value approach, will be the distribution curve, which is skewed to the right for the chi-square. The critical region, which is on the right for the chi-square, and the critical value on the critical point. And as you can see in this example, it was done here. The pair of hypotheses was stated, the null and the alternative. The null is saying that the distribution is random. The alternative is saying that the distribution is not random. And the rule, here it is. The critical region is on the right of the distribution curve, which of course, that is where the null will be rejected, and the unshaded region, that is where the null will not be rejected. Now that third person now is called the test statistic, which has to be calculated. And according to where the test statistics land, then the null will be rejected or not. The formula to calculate the test statistic, here it is. The sum of O minus E all squared divided by E. And for the chi-square test for randomness, the expected value has to be calculated, which will be the average of the observed values. So that would be step number 6. Here it is. Now, once you see the sigma sign, you've got to think of table, and you've got to calculate some values before you add. These values will be called the chi-square contributions. Here they are, 4 of them. This can easily be done in Excel also. You list the observed values. The expected value was calculated to be 46.25. When the observed values were added, 185, and divided by 4, because you have 4 snackers, 46.25. Okay, because if the null is saying that the distribution is random, you expect that each snack can get the same number of customers, right? So that's why the expected values is the same for all the snack booths. And now you've got your O minus E all squared divided by E 4 times. That's 4 chi-square contributions. And when these were added up, you get the chi-square test statistics, which is like our null, which is like our referee or our judge. Yes? So here we're going to demonstrate how you can calculate the test statistic using Excel. You can go to Google Sheets. You can place the observed in a column, place the expected in a column, and you create a formula equal A1 minus B1 all squared divided by B1. Because A1 has the first O, B1 has the first E. And here it is, and you can simply drag the formula. And once you drag the formula, it will be repeated for each cell. And then you can look for the sum sign. Here it is. And you add up the chi-square contributions to get the chi-square test statistic, which of course is like what George had said. So now the judge has to go and speak to make a decision. So as you can see, 10.14 is less than 11. You cannot put 10 on the right side of 11. So 10 is between 0 and 11. And it so happens that is where the null, the judge has to say, do not reject the null. Okay? If the test statistics was here in the critical region, then the decision would be to reject the null. Okay? And that would be step number 7 to 8. 7 is to plot the test statistic, and 8 is to make a decision. You reject the null if the test statistics is located in a critical region. Do not reject the null if the test statistics is located in the unshaded region. Now, step number 9 now is to make a decision. Remember, the two persons are debating. One of them have to win. Okay? If the null is rejected, then it is the conclusion. So it's hooray, I have won the debate. But if the null is rejected, then the alternative will be the conclusion. The alternative will be celebrating that it has won the debate. So in this example, since the null was not rejected, because the test statistic is 10.14, then the conclusion will be the null itself. And you can start by saying, based on the data, the distribution is random, because that's what the null is saying. And there is no factor affecting the patronage according to the data that has been collected here. Summary: always begin with a pair of hypotheses for chi-square test for randomness. The null will be saying the distribution is random. The alternative will be saying that the distribution is not random, because you want to see whether or not one set of values, is it randomly distributed or not. Now we need the rule, which is the distribution curve, with the critical region on the right and the critical value on the critical point. Okay? And you have the unshaded and the shaded region. Now we need to calculate another number called the test statistic, which is like the judge. You can use Excel or Google Sheets for this, because you've got to calculate chi-square contributions, which is O minus E all squared divided by E, and then you've got to add them up to get the chi-square test statistic, which will then be plotted on the curve to see where it lands, and according to where it lands, you make a decision. So in this case, it landed in the do not reject region. So the decision is do not reject the null. And conclusion, since the null was not rejected, it is the conclusion. So that's what we've got to conclude with. Okay? As we say, always remember that you will start the test with two statements, the null and the alternative. After the test is completed, only one will be the conclusion based on the decision that was made. And here, the decision was not to reject the null, so the null is the conclusion.